So hi, in this session we will discuss about how DC to DC converters are used in renewable energy systems. So what is renewable energy systems? Normally we want renewable energy. Yeah, so what is renewable energy? Natural resources. Yeah, good. The energy is obtained from the natural resources. Okay. So before that, can you give any examples? Solar. That is hydro. Wind. Okay. Actually, before, can you anyone explain how this? For example, we can take a solar energy conversion. How the solar energy is converted and it's given to grid or any other appliances? Photovoltaic cells. First, for example, we have a solar panel. From that, we have it obtains the irradiance. Okay, we have a irradiance. Irradiance is the radiations from the sun. Okay. So after that, that will give the supply. We are getting input from the solar input from the sun, and it's we got here. After that, that will give. That will be given to the inverter. No, that is some process. That is the thing we are going to explain. Here we will be doing a process. What is the output of solar panel? Anyone? Somewhat lower. DC. Okay. The output from solar is DC. Then, whether it's constant DC? No. It's a variable DC. You will not get a constant DC there. You will be getting a variable DC. It depends on the irradiance. It depends upon the light obtained from the sun, right? Normally solar energy depends upon the sunlight. So we will not get a constant DC, we will be getting variable DC. So in order to change that, in order to rectify that, what will we be using? We will be using a device. DC to DC converter, good. We will be using a DC to DC converter. So normally the DC to DC converter, what we will be calling it? DC to DC converter, we will be calling it as what? We have a device, right? Chopper, right? Or the switch mode regulator. And what type of, you have to convert what variable to DC, variable DC to what? You have to convert the variable DC supply to what DC supply? Constant. Okay? So now we will be giving to a battery. Will not directly give to the inverter because solar always does not have a supply, right? So we will be storing and we will be using. Okay? So this is the purpose of DC to DC converter in a solar power system. Okay? Now when we are going for wind or any microgrid, what is meant by microgrid? Yeah? Can you just interconnected network. Actually, normally interconnected network we will be calling it as grid, right? Actually, we are connecting n number of, not only given to the utility grid. Microgrid is nothing but, for example, in your home, you have a solar, okay, and you have any biomass energy production and all, okay. So that one we will be calling it as a microgrid. When you are working in hybrid mode, hybrid is n number of sources. You have when you are combining solar and wind, you will be calling it as hybrid energy conversion or hybrid energy system. That is hybrid energy. Microgrid is like a standalone. Either you can use it yourself or you can connect to the utility grid. Utility is nothing but our EB supply. Okay. So how many grids we have in a country? Grid. No. Previously it's 5. Now it's only 1. Okay, only sample has only 1 grid. So our country is connected to a single grid. So that's all. And wind, how does a wind energy system works? Wind energy system. It converts which energy to which energy? Okay, in solar it converts light It's not what?
Kinetic energy.
Kinetic. That is your mechanical energy, right? The wind it captures the wind will move the turbine, that is your that fans in the wind turbine, right? It flows, and because of that, there will be turbine inside the box. So it will rotate the turbine, and you have a mechanical energy. From that, we can convert it to electrical energy. Okay? So that's it with the wind. So normally we will be using everywhere in every sources, every appliances. We will be using DC to DC converter, right? So what are the types of DC to DC converter? You have in choppers. You have step down chopper, step up chopper, right? What is step down chopper? Anyone? It is okay. What it does normally? Boost converter does step up. It increases. Okay. Normally we have a supply voltage and we have an output, right? Your step down, normally a step down converter it reduces. Your output will be less than your supply voltage. In step up, your output will be greater than your supply voltage. Okay, that's all with the step up and step down. And we have to, if we need to do both, it's possible, right?
Yes.
We can use buck boost converter like that. Okay. Okay, here everything depends on which ratio, your conversion rate, your time ratio, your time periods and all, your increasing switching periods and all depends on duty ratio. At what time it should be switched on. Everything we are designing using a power electronic devices, right? It can be IGBT, it can be BJT, it can be MOSFET. Okay, you can design that, but everything will be depending on your duty ratio. Okay, so here in buck boost converter, you have to, it depends on, it will work as a step up or step down depending on your duty ratio. Okay, see, that's all with this, and this is mainly used for your renewable or any other appliances. If you are doing a project, you can see there will be a DC to DC converter. You should know what is the purpose of it always. Okay, thank you.